Hi, good day to each and everyone. For today's video, we are going to talk about conversion of units. So sit back, relax, and enjoy some moment of science with me. For today, we are diving into something fundamental but very important, which is the conversion of units. Whether you are in the lab, solving physics problems, or even cooking at home, understanding how to convert units accurately is very essential. Now, you might be asking, why do we need to convert units? Well, in essence, unit conversion is all about translating a measurement from one unit to another, while keeping the actual quantity the same. For instance, when we say 1 kilometer, that means it's the same as 1,000 meters. The value remains the same, but the representation changes. So let's see how this happens actually. One of the most effective ways that we can convert units is through what we call as dimensional analysis. The key here is to actually set up the conversion as a fraction. For instance, for this particular example that I am going to show you here on my whiteboard, I'm going to set up a sample quantity where I'm going to convert it to another dimension. In this case, allow me to use 1 kilometer. So let's set this for our example, wherein we are going to convert 1 kilometer into meters. Now, to do this, of course, we need to be familiar with the different conversion factors. And in fact, when you browse the internet, you can see lots of conversion factors available. So I will leave the task to you to actually search on this on the web and be familiar with the different conversion factors. The key here is not to actually memorize the conversion factor, but to familiarize yourself with the process of how we convert one unit to another unit. For example, in this instance, we know that the conversion factor for this is that in every 1 kilometer, there is 1,000 meters. So if we are going to convert this using dimensional analysis, it will be written as follows. You write here 1 kilometer, then multiply this with the conversion factor that we have here above, in which I'm going to encircle right now. So in order to cancel the unit of kilometer, we need to see to it that the units assigned must be in fraction with one another. For instance, in order to cancel kilometers here, I need to put the kilometer unit on the denominator and then put the other conversion factor, in this case 1,000 meters, on the numerator. So in this way, I would be able to cancel the kilometers unit. So that would be canceled. So that would mean that in order to convert 1 kilometer to 1,000 meters, I would need to multiply 1 kilometer to 1,000. And that would give us an answer of 1,000 meters. So this process is actually very easy to remember. Just always take note that we have to ensure that units that you want to be cancelled and that they should be set on the opposite with each other in the fraction. Okay? So let's have another example. So let's take, for example, let's think of another unit. In this case, allow me to use foot to meters. So let's say I'm going to convert 3 meters to feet. So how do we approach this conversion process right now? So as what I've said in our earlier example, in order to perform conversion of units, you have to always ensure the units that you want to cancel are set opposite each other in the fraction so that cancellation will happen. So in this way, the first process that we need to do is identify first what are the different conversion factors that we can use in order to convert meters to feet. Okay, so we know that of course 1 inch, oops, sorry, it's not 1 inch, but 1 foot is equivalent to 12 inches. Okay, then I know also that in 1 inch there is also 2.54 centimeters. And I also know that in every 1 meter there is 100 centimeters. Okay, so in this case, we can now set and calculate for different conversion factors for this particular example. So how are we going to do this right now? So allow me to write first 3 meters here on this side. Now, as what I've said, in order to cancel the unit of meters, we need to see to it that the units are set opposite each other in the fraction. So therefore, I'm going to use this conversion factor here and the last one, in which 1 meter is equivalent to 100 centimeters. So if I'm going to calculate this right now, this will become 1 meter is equal to 100 centimeters. So in this way, I would be able to cancel the meters unit. Okay, so now that I have canceled the meters unit, I will need to multiply this again on the second stage because we have not yet arrived at our target conversion, which is to feet. So therefore, I'm going to use the second conversion factor available here in our example, in which 1 inch is equal to 2.54 centimeters. So how am I going to write this down on my fraction? So always remember that in order to cancel the units, they must be set opposite each other in the fraction. So in this case, I'm going to write here 2.54 centimeters is equivalent to 1 inch. So in this way, I would be able to cancel the centimeter unit. Now, what remains now is our inch unit. But again, we haven't done our complete conversion yet because we haven't arrived at the feet unit. So what we're going to do now is apply the last conversion factor, in which 1 foot is equal to 12 inches. So I'm going to write this down in my last process, in which 1 foot is equivalent to 12 inches. So I'm going to write 12 inches here because I would need to cancel the inch unit, and this would become 1 foot. So this will stage the cancellation of the inch unit, and what remains now is the foot unit. Okay, so in this way, we will now be able to identify how do we convert 3 meters to feet. So in this way, to convert 3 meters to feet, we would need to multiply 3 meters by 100, then divide it by 2.54, and then divide it again by 12 inches. So if we are going to do that, allow me to use my calculator here. So if we are going to do that right now, okay, so that means 3 meters multiplied by 100. Okay, and now your 300 meters, we need to divide it with 2.54. That would give us 118.11 to the many decimal points that you can see right now. And then we need to divide it again with 12. Okay, so that would give us an answer around 9.84 feet. So I'm going to round up my answer into 2 decimal places. So that would mean that that is 9.84 feet. Okay, so that would mean that 3 meters here is equivalent to 9.84 feet. Okay, let me box that answer. So this is how we are going to convert feet to meters. But of course, this is somewhat a very long process, but there is a shorter conversion factor available on the internet, but I cannot memorize the complete conversion factor from meters to feet. So that's why I have to stage multiple levels of process so that I could convert it to feet. But anyways, the answer will still be the same using the same conversion factor. So there would be no problem for that. Okay? So I hope that you understood this example. So let's go to the next example. So let's just say that we are going to use the unit for volume. So of course we know volume, right? So let's just say that I want to convert 2.5 liters to milliliters. Okay, so to convert 2.5 liters to milliliters, I would need to know what is the conversion factor from liters to meters. Oh, sorry, liters to milliliters. Okay, so we know that 1 liter is equivalent to 1,000 ml. Okay, so therefore, if I'm going to write 2.5 liters right now, I will multiply it in such a way that I would be able to cancel the liter units. So this would give us 1 liter is equivalent to 1,000 ml. Okay, so this would make the liter unit to be cancelled, and we need to multiply 2.5 by 1,000, and that would give us 2,500 ml. So let's box that answer. So this is how we convert 2.5 liters to milliliters. Now, let me move on to a more complicated example. In this case, we sometimes will be able to face conversion of units wherein it involves multiple dimensions. For example, let's have this for our example number 4. We will deal with the example on speed. So let's just say that I want to convert 20 kilometers per hour to meters per second. Okay? So as you can see here, there are actually two quantities that are involved in this particular example. First one is of course the unit for kilometer. Sorry, let me just use another color. For the unit of kilometer, that is a unit for length, right? And of course, we have our hour, which is of course a unit for time. And the same as with this one, meter is also a unit of length, and of course, our second here is also a unit of time. So therefore, we need to have two conversion factors for the unit of length and for the unit of time. And in this case, we know that 1,000 meters is equivalent to 1 kilometer. Okay? So that's our first conversion unit or factor. So the second one is we know that 1 hour is equivalent to 3,600 seconds. So this is all the information that we need in order to convert 20 kilometers per hour to meters per second. So how do we approach converting this value right now? So the first thing that you need to do is, again, always remember to always write down your values in a sort of a fraction. Okay? So in this case, I'm going to write 20 kilometers per hour like this. Okay? So first is I want to convert kilometers to meters. So what will happen is I'm going to multiply this number in such a way that I could cancel the kilometer unit. So in this case, I'm going to put the kilometer unit below. Okay? So, what will happen now is I'm going to put 1 kilometer and then this would become 1,000 meters here above. And effectively, that will cancel our unit for kilometer. Okay? So, allow me to multiply this. 20 multiplied by 1,000 is of course equivalent to 20,000. So, this time, it will become a meter right now per hour. Okay? So this becomes 20,000 meters per hour right now. Now, the next thing that I would like to convert is, of course, hours to seconds. So in this case, since our hour is now located on the denominator side, I would need to write the hour unit on the numerator side so that I could cancel the hour unit. So in this case, I'm going to write here 1 hour is equal to 3,600 seconds. Okay? This will effectively cancel our unit for time, which is, in this case, hour. And what remains now is the unit for seconds. So, as you can see right now, what remains is meters per second. And that will already complete our conversion for this particular value. So, we will now have to continue with our calculation. In this case, 20,000 divided by 3,600 seconds. So, allow me again to use my calculator on this side. So, that would give us around 20,000 divided by 3,600 seconds. That would give us around 5.56 meters per second, rounded up into 2 decimal places. Allow me to write that down right now. So this becomes 5.56 meters per second. Let's encircle that so that we identify that that is our answer. Okay? So this is how we are going to convert units or values that involves different dimensions. So always remember the process that in order for you to cancel the units in your conversion, you must see to it that you keep track of your units and make sure that they cancel out correctly. And how do we do this is that we set our units so that they would be opposite each other in the fraction. Now, there's one more thing that I forgot to share to you about, and that is how to convert a unit, in this case, one unit of area to another unit of area, or maybe a unit of volume to another unit of volume. So let's take a look at this example. We will convert 5 square meters to square centimeter. Now, we understand that there is no direct conversion factor for square meters to square centimeters. But we do know that there is an existing conversion factor from centimeters to meters. So, allow me to use that one for our example in this particular unit. So, how do we convert square meters now to square centimeters? First, let's try to write what is the existing conversion factor that we know from meters to centimeter. Now, we know that 1 meter is equivalent to 100 centimeters. Now, why do we need to write this? It's because this is somewhat the only conversion factor that we know so far about meters to centimeters. So, since this is square already, this is a unit of area, what we can do here right now is actually to square also this conversion factor so that they can also be expressed into a unit of area. So therefore, we now have a conversion factor for meters squared to centimeters squared by just squaring our existing conversion factor from meters to centimeters. So, let us now try to solve this particular example. We have here 5 square meters. Multiply this in such a way that we can cancel the square meter unit. So that would mean that I'm going to write here 1 meter is equivalent to 100 centimeter. But since that is a squared quantity, then that would mean that I will also square these quantities here so that they will be the same units. So in this case, I will square 1 meter and 100 centimeters so that they will become a unit of area. So as you can see here, 1 meter times 1 meter is of course equal to 1 meter squared. So therefore, I can now cancel the unit of square meters in this particular case. Cancel this, then cancel this. Now, what remains is this 100 centimeter squared. Okay? So that would mean that we need to multiply 5 to the square of 100 centimeter. And of course, we know the square of 100 centimeter, and that is 10,000 square centimeters. Okay? So therefore, to convert 5 square meters to square centimeter, I would need to multiply 5 by 10,000. So what is 5 by 10,000 square centimeters? Then that would give us, of course, 50,000 square centimeters. So this is how we are going to convert this particular example to another unit. I hope that you guys understood this particular example. To wrap things up, these are some of the tips and common mistakes that you must remember when converting one unit to another unit. First, always double check the units to ensure that they cancel out properly. To do this, you have to use dimensional analysis to keep track of your conversions systematically. Always remember the rule that in order to cancel out the units, you must place them opposite with each other in the fraction. Third tip that I would like to share to you is to always be cautious when converting areas or volumes, as these involve squared or cubed units. So always remember the process that I showed you in our last example for this. And lastly, a common mistake is forgetting to square or cube the conversion factor when dealing with areas and volumes. For example, when we deal with meters squared to centimeters squared, it always requires squaring the existing conversion factor. Okay, so that's it, and I hope that you learned something out from our discussion for today. So to wrap things up, why do we need to convert units? It's because, again, we need to express some units in other equivalent units because not all places use the same units as we do. Although there is a need for us to convert units, the values will always be the same. So I hope that you learned something out from our discussion for this morning. So until next time, so I hope that we'll be able to join once again with one another to another episode in our Moment of Science with Mr. Rabino. So goodbye for now. So I hope that you enjoyed this very quick lesson on unit conversion. Keep practicing and always remember, measurements may change their units, but their values will always stay the same. Don't forget to like and subscribe and hit the notification bell for more. A Moment of Science with Mr. Rabino. See you next time.